All right, problem 3, work 8. This is one where we're taking the Lorentz magnetic force, okay, as Fe QE. If you had an electric field, and Lorentz force is both of them, plus the magnetic part. And we're twisting it around, we're applying it to a wire. What happens to, instead of a charge that's moving in a magnetic field, what happens to a bunch of charges in a straight wire? Okay, we're in a crooked wire. We're going to integrate over dl. Okay, and we're applying that in problem 3 to a wire loop that's going through this weird magnetic field. I say it's weird because if I'm just drawing it in the xy plane, it's a function of x and it's smallest at x equals 0. Okay, and we'll call it wire 1, 2, 3, and 4. It's carrying some current I that's the same in each of the legs. It's a circulating thing. And so we're going to have to integrate this up to find the total force on this wire loop. And this is how all these motors work. There's a loop and it's experiencing a force due to these moving charges in the magnetic field. And integrate around that loop. I is going to be constant, however many amps this thing is carrying. dl cross B. Okay, can we move any of these things out? We can for the first wire because we're at x equals 0. We're going to have B equals 0. Okay, and when we're doing this whole integral, we're going to have to add it up. Equals force on 1 plus dl cross B over leg 2 plus dl cross B over leg 3 plus dl cross B over leg 4. We're going to have to do a lot of right-hand rule stuff, except for the first one where we're going to see that B is 0. On leg 3, it's kind of nice because B is a constant, and in the problem statement, it says what x is at this point. I just want to go kind of general. Z hat, okay, x cross y is z hat this way. Magnetic field is coming out at us right there. It's got a constant magnitude because we're at a constant x right here on leg 3. That's nice. So we're going to go I dl, dl is always in the I direction, cross B. Okay, we're going to have to curl. This is easier if I put B like this. Curl our fingers, dl cross B, and my thumb is going to point out this way. This wire 3 is getting a force out like that. These other two segments we're going to see, and you can look at the key, that they cancel out. B is varying over this thing. It's getting bigger and bigger and bigger as you're out here. There's 0 here. And that's kind of a bummer because you have to integrate. This is changing along dl, but 2 and 4 are equal and opposite, so those are going to cancel. Then you're left just doing ILB for 3 because everything's at right angles. So check out the key for details.